how to kickstart your business with artificial intelligence. The anatomy of modern AI, understanding its components and capabilities. Part 2. Module Introduction. In our last module, we learned about AI and how it impacts our daily lives. Now, let's dive into modern AI. We'll explore the basics, including big data and machine learning, to help you get started with understanding this exciting technology. Ready to explore modern AI? In our last module, we learned about big data and why it's important for AI. Then we'll discover machine learning, including its different types. In this module, we'll dive into deep learning and find out what makes it so cool. What is deep learning? Let's talk about deep learning now. It's a type of machine learning that uses something called artificial neural networks to learn and process information. This is like how humans learn and process information in our brains. These networks are made up of layers, like layers of a cake, and each layer helps the computer to understand the information a little better. That's why it's called deep learning, because there are many layers involved. Have you ever heard of a brain? It's a super powerful machine that helps us think, learn, and remember things. Well, scientists have created something similar for computers called a neural network. It's made up of lots of tiny parts called nodes that work together like a team to understand information, just like our brain does. In the past, it was hard to make really big and complex neural networks because computers weren't powerful enough. But today, we have special tools and resources that allow us to make much bigger and smarter neural networks that can help computers learn and think like humans do. Neural networks are like a big group of brain cells that help computers understand things, kind of like how we understand things with our own brains. In the past, it was hard to make these networks really big and complicated because computers weren't powerful enough. But now we have better technology, so we can make these networks bigger and better than ever before. And they can even learn and make decisions faster than humans in some cases. Oh, and one more thing, people didn't talk about deep learning very much for a long time, but in 2014, it became really popular all around the world. Deep learning became more popular around the end of 2014 for a few reasons. One reason is that deep learning requires large amounts of data, and the devices that collect data like smartphones and cameras became much more common in the 2010. Another reason is that deep learning requires a lot of computational power, and as computers became more powerful and cheaper, it became easier to run complex deep learning algorithms. So, these advancements allowed researchers and companies to use deep learning to solve more complex problems and create more powerful artificial intelligence systems. Deep learning uses more advanced techniques than traditional machine learning, and one big reason we prefer it is because it can perform better. If we compare the amount of data needed to achieve good performance, deep learning requires less data than traditional machine learning. This means that with a smaller amount of data, deep learning can do a better job at analyzing and making decisions than traditional machine learning. One of the big reasons we prefer deep learning over traditional machine learning is because it can perform better when we have a lot of data. Imagine you're learning to play a new game. At first, you might be really bad and make a lot of mistakes, but as you practice and learn more, you get better and better. Deep learning is kind of like that. The more data it has, the more it can learn and improve. Traditional machine learning, on the other hand, has a limit to how much it can learn from data. Another difference is how the algorithm identifies which parts of the data are important for making predictions. In traditional machine learning, we have to manually tell the algorithm which parts of the data to focus on. In deep learning, the algorithm can figure this out on its own by analyzing the data using lots of interconnected nodes in a neural network. In traditional machine learning, experts have to identify the important features of the data to help the algorithm make predictions. These features could be things like color, texture, shape, or position. But sometimes the experts might not choose the best features, which can lead to less accurate predictions. But in deep learning, the algorithm itself can figure out which features are important. This is because deep learning uses complex neural networks that can analyze lots of data and find patterns on their own. So, deep learning can be more accurate and efficient than traditional machine learning. In traditional machine learning, experts have to manually decide which features are important for the algorithm to predict. But in deep learning, the algorithm can figure out which features are important by itself. This means we don't need experts to tell the algorithm what to look for every time we want to solve a new problem, making it more efficient. Although deep learning is a powerful technique, it's not the best solution for every problem. It can be more complex and take longer to process, which means it might not work for situations where we need quick answers. Before using deep learning, we need to think carefully about the problem we're trying to solve and whether it's the right technique to use. How does deep learning work? Have you ever heard of deep learning? It's a really cool way that computers can learn and make decisions just like people do. But to understand deep learning, you need to first learn about something called a neural network. A neural network is like a big puzzle made up of lots of little pieces called nodes. These nodes are connected to each other and they work together to help the computer understand information and recognize patterns, just like how our brains work. So, let's say we want to teach a computer to recognize pictures of cats. We would feed the computer lots of pictures of cats, and the neural network would use these pictures to learn what features make up a cat, like pointy ears, a furry tail, and whiskers. Once the neural network has learned what a cat looks like, we can show it new pictures and ask it to tell us whether or not there's a cat in the picture. The neural network would look at the picture and compare it to the features it's learned, and then make a decision based on what it sees. But here's the really cool thing about deep learning. Neural networks can learn and make decisions much faster than humans in some cases. This is because they can process huge amounts of data really quickly. Of course, deep learning isn't always the best solution for every problem because it can be very complex and time-consuming. But for certain tasks, like recognizing patterns in pictures or language, it can be really powerful. So, next time you hear about deep learning, remember that it's all about using neural networks to help computers learn and make decisions just like our brains do. When we talk about deep learning, we're talking about something that works kind of like a computer brain. The main idea behind it is to make machines smart enough to learn and understand things like we do. To make this happen, we use something called a neural network. A neural network is a bunch of little parts that work together to help the machine learn. Here's what a typical neural network looks like. Don't worry if it looks complicated. I'll explain it in a simple way. Each circle you see in the picture represents something called an artificial neuron. Think of these like little computer brains that are all connected together. They're kind of like the neurons in our own brains, which help us think and learn. So when we talk about deep learning, we're really talking about using lots of these artificial neurons to help machines learn and make sense of things. Pretty cool, huh? Remember how our brains have tiny cells called neurons that help us think and process information? Well, in deep learning, we use artificial neurons to help computers think and learn too. A neural network is made up of lots of these artificial neurons that are connected to each other by lines called arrows. These arrows show how information flows from one neuron to another. There are 3 different types of layers in a neural network: the input layer, the hidden layer, and the output layer. The input layer is where we put in the information we want the network to learn from. The hidden layer is where the network does most of its thinking and learning. And finally, the output layer is where the network gives us its answer or prediction. So, think of a neural network like a bunch of tiny robots that talk to each other using arrows. Each robot has a special job, and together they can help computers learn and make predictions just like our brains do. After cleaning up the data, we send it to the input layer of the neural network. Then, the data moves to the hidden layer, which is like the brain of the network. The number of hidden layers in the network determines how difficult a problem it can solve. This network has 2 hidden layers. Each layer has many artificial neurons that work together to process the data and make predictions. Finally, the output layer gives us the results of the network's predictions. Let's take a closer look at how a neural network works. Imagine that you have a puzzle and you want to solve it. You have to put the puzzle pieces together in the right order to solve it, right? Well, neural networks work kind of like that. The puzzle pieces are like the data that the neural network needs to work with. First, the data is cleaned and prepared, and then it's sent to the input layer of the neural network. The input layer is like the first set of puzzle pieces. Then the data moves on to the hidden layers of the network. This is like putting more and more puzzle pieces together until you start to see the bigger picture. The more hidden layers a network has, the more complex the problems it can solve. Finally, the data goes to the output layer, which gives us the answer we were looking for, just like when you finish the puzzle and see the complete picture. Each connection between the nodes in the network has a weight, which is like the importance of that connection. The network will try different weights and see which ones work best to solve the problem. So, a neural network is like a puzzle solver, and the weights are like the importance of the connections between the puzzle pieces. By trying different weights, the neural network can solve all sorts of problems. Let's see how all of these parts come together and work. The first part is called forward propagation. During this step, information flows from the input layer to the output layer like a wave moving forward. Firstly, the neural network randomly initializes the weights. These weights are like the strength of the connections between the neurons. Then, the neural network takes the input data and multiplies it with the weights. This gives us the output of the first layer. The output of the first layer then becomes the input for the next layer, and this process continues until we get to the output layer. At the output layer, we get the result that we need. This is the part of the network that gives us the answer to our problem. This process of moving forward through the network is called forward propagation. I'll reiterate to ensure better comprehension. Now that the neural network is set up, it's time to put it to work. The first step is called forward propagation, which means that information flows from the input layer to the output layer. To start, the data is sent to the input layer where it is converted into numbers. Then, each of these numbers is multiplied by a weight, which is a special number that the neural network needs to figure out. The multiplied values are then passed to the hidden layer, which is the brain of the neural network. The hidden layer is where all the magic happens. Each node in the input layer is connected to every node in the hidden layer, so there are lots of connections to keep track of. Don't worry if this all sounds a bit confusing, it can take a while to get your head around. But just remember that the neural network is like a big web of connections, and every node and weight plays a role in helping the network make predictions. Now, we come to the second and final stage called backpropagation. This is where the network learns from its mistakes and improves its accuracy. First, the network compares its predicted output to the actual output. This is like checking if the answer you got is correct or not. Once the neural network has made its best guess, we need to check how accurate it was. We do this by comparing the predicted output to the actual output we already know. If the network made some mistakes, we need to help it learn from them. In the second stage called backpropagation, we use a technique called gradient descent to adjust the weights in the network. This means that the network will focus more on the parts of the input data that are important for getting the right output. It's like when you learn how to ride a bike and you try it out for the first time. You may make some mistakes and fall off, but as you keep practicing and getting feedback, you adjust your balance and get better at it. Think of a basketball player practicing their free throws. At first, they might miss a lot, but they keep practicing and making adjustments until they start making more shots. This is similar to what a neural network does in backpropagation. It keeps adjusting its weights and making improvements until it can make accurate predictions. This process is repeated many times until the network can solve the problem with the desired accuracy. Once the network has learned the patterns in the data, it can then be used to make predictions on new data that it has never seen before. That, in a nutshell, is how a neural network works. It probably might be a good idea to watch this video one more time because it is very important for a conceptual understanding of what goes on behind the scenes in deep learning. Let's wrap it up for now. We'll bring you more informative content in our next video. If you have any questions, please leave them in the comments below. And don't forget to subscribe and share this video. Thank you for watching.